All right, everyone, we're going to take a look at our forces worksheet that we were working on for homework last night. We've got 3 or 4 questions that we need to go over here. Number 7, number 13, number 14. Let's take a look at number 7 first. Calculate the acceleration of this system down here. Well, we see a pulley. What do we want to do when we see a pulley? Usually we want to straighten it out. We don't have to. It's not critical that we straighten it out, but it's usually helpful to us if we do. So let's do that now. Let's take the 6 kilogram object and let's pull it up like this, so that we have a 2 kilogram object on a horizontal surface and a 6 kilogram object on a horizontal surface. If I do that, that means I have a force of friction acting to the left. Now, technically, that's on only the 2 kilogram object, but the effect of that is on the entire system as well. Anything else? There is something else, obviously, guys. You can't have friction if there's no other force. Friction cannot provide for you a force that is an unbalanced force in the opposite direction. So in other words, friction can't speed you up to the left, right? If anything, it's going to slow us down or stop us. There's got to be another force acting. It's going to be the force of gravity acting on this 6 kilogram object, which is going to be 6 times 9.81. And we're going to make that positive because it's to the right. I think that's, Victoria, I think that's 58.86, right? 58.86 newtons. All right. Let's say now F net is equal to the sum of the forces. That's FF plus FG. Now what mass do I use here? MJ, what mass do I use? Sorry? Sure you do. What mass do you think that I use? Yeah, that's the whole mass. Who asked me for number 7? Okay, I was thinking it was Bree, actually. We use the entire mass, right? So that's going to be 8 kilograms times the acceleration, which we don't know. That's what we're trying to find. The force of friction, Colleen, is 20 newtons. The force of gravity is 58.86 newtons, right? Is that right? Yeah. That's why you made a mistake, because we're missing something there. It's a small thing, but it's important. What's negative? Good, negative 20. So it becomes 8 times A is equal to 38.86. Now, 38 divided by 8 is somewhere in the range of almost 5, 4.75, I'm going to say. 4.8. Anybody have it? I guess I have it. If I look at my answer sheet, 4.9, I guess it is, right? 4.9 meters per second squared. Colleen, is that okay? Where was the mistake? Okay, fair enough. The next question that we wanted to go over was number 13. So let's take a look at that one. So let's calculate the force of friction. I know a number of people asked me about this. They were puzzled by that FA. What is that FA, people said? And my response to a number of people was, it doesn't matter. Who cares what it is? It's just a force. Maybe it's the force of a tow truck pulling it up the hill. Maybe it's the force of a wind pushing it up the hill. Maybe it's the force of the dogs and the dog sled pulling. It doesn't matter what it is, right? It's a force up the hill. An applied force, that's what it stands for, is FA, applied force. But again, it doesn't really matter. It's a force that acts up the hill. Now, we know that we also have an F parallel. I'm just going to make this bigger so I've got some space to draw here. We've also got an F parallel. So let's draw in the forces that are required to get me F parallel. We know we have gravity acting down. We know we have a normal force acting at 90 degrees here. And we know that we have an F parallel that's acting this way. Now, as I was helping a number of you, scheduled help or during class yesterday, lots of you didn't draw the diagram. And I told you guys, draw the picture, draw the free body diagram. Lots of you didn't, because lots of you remembered that, hey, it's always going to work out to be the sine function. Sine 30 degrees is equal to opposite over the hypotenuse. Therefore, F parallel will always be equal to M times G times sine 30, which in this case works out to be 49.05 newtons. Lots of you will remember that. The problem is, are you going to remember that in 3 months when you have a final exam? Maybe. Maybe you'll remember its sign, or maybe you won't. If you know how to draw it and you draw it properly, okay, you won't forget that. You won't get mixed up between sine and cos and tan. Right now, you're not getting mixed up because we just did it yesterday. 3 months from now, and it's a lot further removed in your mind, there's a lot better chance you're getting mixed up. So draw that picture, please. Opposite over hypotenuse, sine function. Okay, if you don't draw it, then you're going to miss that. All right, let's label F parallel there, 49.05. Now, we want to find the force of friction. Jared, which way is friction going to act? If we've got a force applied, or whatever force of 80 newtons up the hill, and we've got 49.05 down the hill, which is really just a combination of the normal force and gravity. Which way does friction act? Resist. What does it resist exactly? Resist motion. Which way is it going to move, Jared? Why? 49. Okay. Well, we have a force up the hill of 80, right? So which one's bigger? Which one's bigger, Sam? The 80 is bigger, right? So it's going to go up the hill. Because it's going to go up the hill, then friction's going to act which way? Like this. Friction's going to act down. Right? Friction's going to act to oppose the motion. If it moves up the hill, friction's going to act down the hill. Right, Jared, does that make sense? 80 up, 49 down, friction's going to act down the hill. Now, we don't know how big friction is. We don't know how big the force of friction is, right, Victoria? We don't know how big friction is. We're going to solve for that, right? That's what we're going to solve for, right? So let's say, and now F net is equal to the sum of the forces. F parallel plus FF plus FA. I'll tell you what, Jared, you missed the direction of that force of friction there. You get away with it here. Because in the end, when you solve for it in this question is going to tell you whether it's up the hill or down the hill. So even if I drew it wrong, drew it up the hill, I'd still get the right answer there. It's more to help me visualize it. All right, net force is mass times acceleration. The mass is 10 kilograms. The acceleration is 1.5. It's up the hill, so we'll make it positive. F parallel is neg 49.05 plus FF plus FA, which is positive 80. Okay, this is going to give me, combine those, it gives me 30.95. 15 minus 30.95 gives me negative 16 newtons for FF. Which, was I right when I guessed? No, I wasn't a guess exactly, but was I right when I assumed that the force of friction was going to be down the hill? Of course I was, right? We got a negative value for friction. Of course I was right. Yeah. I'm not always right, but I know that I'm right this time because we said it was going down the hill. Look, we got a negative value down the hill. That good? Okay, let's try number 14. Good question, number 14. Fourteen says find the acceleration. So similar to question 13, except we've got this 5 kilogram object right here that's hanging over the edge of a pulley and pulling this system down. Okay. Let's not deal with the second 5 kilogram object yet. Let's deal with F parallel. Here's the force of gravity. Here's the normal force. And remember that F parallel is perpendicular to the normal force, and it's parallel to the hill itself. I used to call that FH for the force of the hill. but now I just call it F parallel to remind you that it's the force that's parallel to the hill. We've got another force acting here as well. It doesn't say friction, but we got another force acting this way. Okay, that's going to be force of gravity, which is 5 times 9.81, which is 49.05. Let's straighten it out, though. Okay, let's straighten it out to hopefully make it a little bit less confusing for us. We get an F parallel acting this way. We haven't figured that out. Let's figure it out. Sine 30 is equal to opposite, which is F parallel, over 5 times 9.81. 24 point, who's got that? 5.2, 5.25, thank you. So we're going to say 24.525 to the left, 49.05 to the right. Hey, I've left off gravity and the normal force there, right? I've left it off in this new free body diagram that I've drawn. Okay. Sometimes it's okay to leave things off, but you can't just arbitrarily drop things. Have I done that? Sam, have I arbitrarily dropped Fn and Fg, or have I done something that's legal, something that's okay? Yeah, I have. Why is it okay? Why is it okay to not put in Fn and Fg there? Yeah, it's already included in F parallel. We are including Fn and Fg right there. F parallel is Fn and Fg combined. That's why we found it. So let's say F net is equal to the sum of the forces, F parallel plus Fg. M times A, what mass? 5, or 10? Jordan, what do you say? What do you use for mass there? Yes. Let's use the 10 kilogram mass there. We'll multiply that by the acceleration, which we're looking for, negative 24.525 plus 49.05 newtons. We combine those, divide by 10, we get 2.5 meters per second squared. Is it good? How are you doing for number 12 now, do you think? Okay. I can go over it if you want.
Oh, I think I just keep dividing.
Okay. So a math thing, not a physics thing. Okay. Let's try this one since you guys seem to have mastered all those inclined plane problems on the worksheet. 3.18 on page 186 says a 50 kilogram toboggan, that's a heavy toboggan, eh? On a snowy hill. If the hill forms an angle of at least 20 degrees with the horizontal, the toboggan just begins to slide downhill. All right. Stop right there for a second. Forget about the picture, forget about what they're asking, forget about everything else in the question. First sentence, 50 kilogram toboggan on a snowy hill. The hill forms an angle with 20 degrees. The toboggan just begins to slide downhill. What does that remind you of? It just begins to move. Static friction, right? Maximum force of static friction. We're probably dealing with some kind of static friction issue in this question, right? Just keep that in the back of your mind. Okay, maybe even just jot it down, write it down beside the question to remind you. Okay, but something, probably static friction. Certainly it's relevant, or sorry, certainly it's correct. Whether it's actually relevant to the question, we're not positive, but we know that it's not wrong for sure. We're going to find, oh, look at that. We want to calculate the coefficient of static friction. All right. Let's draw the force of gravity down. Let's draw the normal force at 90 degrees. Let's draw F parallel. Remember with projectile motion, I told you guys to always start a certain way. X and Y components, V equals D over T, D is equal to VIT plus 1/2 AT squared. Always. When you see an inclined plane problem like this, you should probably always start with the force parallel. At least if you don't know what else to do, start with F parallel, because it's always valid. Let's get that value. Let's get that force parallel, and then we'll go from there. Let's say sine 20 degrees is equal to opposite over hypotenuse. So F parallel is equal to 50 kilograms times 9.81 times sine 20 degrees. Gives us 167.76. Thank you, Bray. All right, so let's label that there as F parallel. All right, now what? Now what? That's the only force I have acting, right? Other than friction. Which way is friction going to act? Which way is friction going to act, guys? Up. Does anybody know what the value of friction might be up the hill? The maximum force of static friction before it begins to move? Good. Same number, right? Same number. Right? The force that's required to get it moving is F parallel, 167 newtons. That is the force of static friction, at least the max force of static friction. So we get two forces acting. They're opposing each other. Not quite drawn to the same length, it doesn't look like. That's a little bit better. All right. We've just figured out what the force of static friction is. Guys, we can actually avoid doing this whole net force thing, right? We can avoid doing that. We've got the max force of static friction. We're looking for the coefficient. So let's say F, Julia, let's say what? FSF max is equal to mu, the coefficient of static friction, times the normal force. Let's just rearrange this and solve for mu. So we're going to say 167.76 divided by the normal force, which would be 50 times 9.81, right? Gives me whatever. I'm not actually going to solve that because it's not right. What's wrong there, man?
Isn't the normal force
Yeah, the normal force, we've said in all these friction problems up till now, the normal force is the same as gravity, right? It's not here, though. Look at my diagram. Gravity is acting straight down. The normal force acts up at an angle. Those two forces don't cancel each other. There is a net force. And all those other problems we were doing involving friction before, they canceled each other. The net force was zero. Here, the net force between this and this is this. We need to find the normal force. It's not m times g. But we can find this. Nathan? Why do you say a cosine? Good. Good. So let's say cosine 20 degrees, right here, is equal to adjacent over the hypotenuse, which is Fn over Fg. So Fn is going to be equal to not 50 times 9.81 times sine 20, but 50 times 9.81 times cosine 20. $460.91, thank you. Now 167 divided by 460 gives me 0.3639, no units. And we're going to round that to how many digits? 2 digits, 3 digits, 0.36, 2 digits. Right? Kind of a tricky one, eh? Funny enough, it's maybe less work than some of the other courses we've done. But just had to think a little bit on your feet on that one, right? Here, we've never found the normal force when it hasn't been equal to gravity before. Now we have. It wasn't hard, though. If you can get F parallel, then you get Fn. Hey, do you see why it's even more important now to draw the diagram? Normal force is cosine. F parallel is sine. How easy is it going to be to mix those two up on your final exam? Okay. You don't have to worry about mixing those up on your final exam if you draw the picture and know a little bit of trigonometry. Jeremy? Okay, it's a good question. I knew that would come up. Jeremy said, wouldn't it be easier to use the Pythagorean theorem to find Fn? There. Listen, we got Fg, you got F parallel now. Couldn't you use the Pythagorean theorem? I wouldn't say it would be easier, no, but you could. A squared plus B squared equals C squared, I don't think is any easier than cosine 20 is equal to Fn over Fg, but it's valid. The danger with that, Jeremy, is that if you've made a mistake right here with the 167, then your Fn would also be incorrect because you're basing the Pythagorean theorem on that number as well. If we've made a mistake right there and we do it this way, then this is still going to be a right number. Does that make sense? If you're right, though, hey, if you're right with F parallel, Pythagorean theorem is just fine. Confidence, right? You're confident with that number. If you are, then go ahead and do it that way. Good? All right, try those two questions, please. Number 2 says an 80 kilogram skier on a slushy surface starts moving down a hill, forming at an angle of at least 25 degrees at the horizontal. Determine the coefficient of static friction, the maximum force of static friction. We're going to need to find B before we find A. Here's our hill. Here's our 25-degree angle. Okay, here's our skier. We know that there's a force of gravity acting down on the skier, m times g. We know that there's a normal force acting perpendicular to the skier, and we know that there's a force of the hill acting this way, which is 90 degrees to the normal force and parallel to the hill. That's going to be F parallel. Let's get the value of F parallel right now, okay, before we do anything else. If you don't know what to do, get F parallel, because it's always valid, right? You're always going to need to find that. Sine 25 degrees is equal to opposite over hypotenuse. So we're going to say F parallel, take the FG up by multiplying, it becomes 80 times 9.81 times sine 25. Gives me a force of what? I'm thinking 3.3 times 10 to the 2. Is that right? Oh, wasn't that fast? Lightning fast calculation. That's the force of the hill, but we know that that's the same as the force of friction. Got to be the same force. Because if this angle is just required to get it going, then that F parallel is just required to get it going. And if that F parallel is just required to get it going, it's got to be the maximum force of static friction. Now, we're going to say cosine 25 degrees is equal to adjacent over hypotenuse. Now we want the normal force, because if we're going to find the coefficient of friction from FSF max, then we got to get the normal force first. Fn is equal to 80 times 9.81 times, wait a second, yeah, times 9.81 times cosine 25. What does that work out to be? What does the normal force there work out to be? Yep. 711.27 newtons. Now that we have the normal force and we have the max force of static friction, now we can find the coefficient. FSF max, which we have, is equal to mu times Fn, which we have. So we're going to say mu s, coefficient of static friction, is FSF max divided by Fn. Okay, do the math there. Should work out to be 0.47, I presume. All right. You guys feel okay about that? And look at where we are. I mean, seriously, look at the board right now with cosine and sine on it, and look at where we were 2 months ago. Seriously, 2 months ago, you guys were struggling with, when I said I walk 10 meters to the north and 6 meters to the south, what's my displacement? And now look at where you are, right? Now, I mean, I'm not saying that this is easy and that everybody's going to nail this question if we have a test. Okay, hopefully you will. But we're all in this place where we more or less, at least, get this topic, right? You're going to love this one. Here's a challenge question for you if you ever saw one. You get an inclined plane, a hill. Now, on this hill is a 500 kilogram object. It's at an angle of 30 degrees. Hey, and that's good news because sine 30 is 0.5. 30-degree angle always makes life a little bit easier for you. Starting off really easy, right? Got a pulley up here, though. That makes things a little bit more confusing, but you can deal with that. Oh, we got a coefficient of static friction of 0.2 and a coefficient of kinetic friction of 0.1. So we got to decide whether it moves to determine which coefficient of friction we need to use. And then once we decide whether it moves, we got to do something else with it. What are these masks sticking up there? Oh, that's the elevator. With the guy inside the elevator. What is that, 20 meters per second there? 30, another 30 degrees. Oh, I see what that is. That's the ball that's being thrown from the elevator at an angle of 30 degrees. After the elevator's been allowed to move for 4 seconds. Hey, I just kind of gave something away, didn't I? It moves. It moves for 4 seconds. So it's going to be kinetic friction. It moves for 4 seconds. As it goes up for 4 seconds, the guy releases the ball at an angle of 30 degrees and 20 meters per second relative to the elevator. The ball goes out here somewhere. The question is, where's the ball going to go? Now, this is what you would call a challenge question. It is the question. I'm not going to do this for you right now. Okay, you've got about 13 minutes. You're going to work on this question. Now, lots of you are probably thinking right now, like, I have no idea. I have no idea what to do here. Yes, you do. Most of you will probably not get the correct answer. I am perfectly fine with you not getting the correct answer. The point of this question is not so much to get the correct answer. That's a bonus. If any of you do, then that's wonderful. The point of this question is to show you that, hey, look, even when you see something that looks impossible, if you break it down into small components, you can actually do a good part of this question. Okay, all of you can do a real big part of this question. You may not get it right because there's a couple real tricky things in there. But for the most part, it's actually pretty straightforward. It's just lots of different pieces. It's the inclined plane. It's the pulley. It's the elevator problem. It's the projectile motion problem. You know how to do all that. Do them separately from one another. And then just kind of try to put them all together. All right? So you've got about 12 minutes to work on that question now. I'd like you to do that, please. And then I'd like you to give it some time at home tonight, too. I'm not expecting you to take an hour to solve this question at home. Okay, but if you can take even 20 minutes tonight to do as much as you can, then that's what we're really looking for here, okay?